This video is going to walk us through one of the laws of logs in our Pre-Calculus 30 class, and it's the multiplication law of logs. Now, all of the laws that we'll examine in this series of videos are available on our formula sheet under the law of logarithms. Now, the multiplication law of logs is stated here in generic form. It's basically saying any log that has the stuff being a multiplication of two terms can be broken up into an addition of two separate logs with the stuff separated. So we'll look at this through a few examples and we'll discuss how to do these. So expand log of x times y. Well, right here we can see our stuff is a multiplication. So this simply expands into two separate logs that are being added together, one being log of x, one being log of y. So log of xy is the same thing or is equal to the log of x plus the log of y. The second example isn't any more difficult. We can see that we do have multiplication happening again. So we can separate both of these into log of 3a plus log of 2b. Now that's one separation using the multiplication law of logs, but I can even take it a step further with the 3a and the 2b. That's multiplication as well. So this can break up into log of 3 plus log of a, that's the multiplication law here, plus log of 2 plus log of b. Here's another separation using the multiplication law of logs. The next example has log of x plus y. Now if you examine closely, the stuff here is not being multiplied. So the tendency is to still split this up as log x plus log y. But if you examine the law on your formula sheet or up here in the corner, you see the only time we can separate it into an addition of separate logs is if there's actually a multiplication happening within those brackets, and there isn't in this case. So here, to expand this, we would simply say cannot be expanded. It's a sum in the brackets for the stuff instead of a multiplication. Now example 4 takes it in reverse. It's actually saying, okay, I have log base 10 of 3 plus log base 10 of 4, and it's asking you to condense it. So put it into a single log if possible. Since the bases are the same on the logs, which is base 10, and there's an addition, I can use the multiplication law of logs backwards, which basically would say, okay, I can have one log base 10, but now I can multiply those stuffs together, and that leaves me with log base 10 of 12. The fifth example now starts to work in polynomials with logs. So variables are now being introduced here. Nothing changes except you have to now be aware of how polynomials operate. So here we have a sum of two separate logs, both base 10, which means I can condense them and multiply their stuffs together. So this would be log base 10 of x plus 1 multiplied by x minus 2. And if you examine this and think back to grade 10, here is a situation where I need to FOIL or do a double distribution to multiply these two polynomials together. So we should be able to, and I'd be hoping that you'd be confident enough to realize that those two polynomials multiplied together are x squared minus x plus 2. So I took these two addition of logs and changed it into one simple log form with a trinomial stuff. The next example also focuses on x's and y's, so there's polynomials there, but there is also a coefficient of a in front of both these, and it's asking you to condense this. So if we could try to use this multiplication law of logs to combine them. Again, we can see they both have a coefficient of a, so that is our greatest common factor, our GCF. So if I factored that out, I'd have a log x plus log y. So I factored out the common term of a in both of them. Now inside the brackets, we have an addition of logs to the same base, so the multiplication law of logs does apply. This would simplify to a log x times y. So we condensed it. The last example on this page takes it a step further and forces us to examine for the multiplication law of logs and as well look for solving for the value of y within this log equation. So if we look on the right hand side, I have an addition of two logs, both with base a, which means I can change this using the multiplication law of logs to log base a of x times y. So I combine that together, and that should equal 2. Now we have to solve for y. Y is inside here, and we had mentioned earlier in class that log base a of anything behind it, this can't be separated. I can't simply divide out a log base a of x and be left with y. That's impossible here. So when I'm trying to solve for something that's inside those brackets, what I should probably look for then is, can I change this into exponential form? Which I can. I have a base a, so I'd have a. Remember, the answer to a log is an exponent, so a squared, that's where that 2 goes, would equal xy. So now I changed that log form into exponential form. Now solving for y should be a little easier, because if I just rewrite this up here, a squared equals x times y. To solve for y, we divide out the x, and we're left with y equals a squared over x. So we use the multiplication law of logs to solve for y. So now your goal, your task, is to work on the next page here. It has some questions with the multiplication law of logs and some solving. If you need to look up some answers, you can look at puremath30.com and search for this lesson, and you can find your answers there.